So starting with Z6, where are my Z6 group? All right, what were the two subgroups that you came up with? 0 to 4.
And the other one was 0, 1, 5.
Say it again.
0, 1, 5.
0, 1, 5. Okay. Let's go to the D3 group. What were your two subgroups that you came up with? I, R squared.
And
I and T. Okay. How about the U9 group? Where's my U9s? Is that? Well, I know you had one example when I came through last, which was 1, 2, 4, 8. 1, 5. So I'll come back and vet these later. And then how about U7? What were your?
1, 2, 4.
1, 2, 4.
And 1, 6.
And 1, 6. Okay. So I will say that not every example of a subgroup up here that you've proffered is actually a subgroup. In particular, take a look at this one, 0, 1, 5. Why am I claiming that that's not, in fact, a subgroup? It's got identity. It's got inverses. What doesn't it have? Closure. Why doesn't it have closure? Because we don't have 1 plus 1. Yeah. So if I have 1, I also have to have, and if I have 2 and 1, I also have to have, if I have 1 and 3, I have to have. So in fact, any subgroup of Z6 which contains 1 will have to be what? It has to be the entire group, which is fine. I mean, that's a non-trivial subgroup also, right? I also, I think, have a problem with 1, 2, 4, 8 as an example. Say again? It's missing 5, and why does it need to have 5? 8 times 4 is 32, which mod 9 is 5. Is it really? Okay. Okay, sure. And if it has those, what else does it have to have? It also has to have 7. So, yeah, actually, U9 has that same problem also. But tell me about 1 comma 5. 5 times 5 is 25. And mod 9...
I think similar to
1, 8. Because 8 times 8 is 64, which mod 9 is 64 is 1 mod 9. Right? 8 times 8 is 1, in other words, in U9. Right? And so, yeah, so this works for the same reason that this works. 6 times 6 is 36, which is 1 mod 7. Okay, great. So last parting shot then. Can we tell, just facially here, whether all 4 of these groups are different? Is there one group that for sure is different than the others on this list? What are some ways, let's just close with this then. What are some ways of investigating that question? If we're going to turn up differences between these groups, what are some ways to find them? What about the operation? Because the operation is everything in abstract algebra. But how specifically can we investigate whether the operations are different? So there's one way. Are all 4 of these groups abelian? Their order. The order of the groups. What are the orders of these 4 groups? All 4 of these groups have order 6. So, yeah, order is a good way to turn up a difference, but in this case, it doesn't turn up a difference between these groups. Commutativity, right? Are the groups abelian?
Order of an element, like of the elements determined.
Orders of elements. Yeah, exactly. In fact, I think we've listed kind of all the tools that we have right now to turn up differences between groups. Check to see whether or not the groups are abelian, because a group that is abelian is definitely different than a group that is not. Check the order of the group. In this case, all of these groups have order 6, and so that doesn't turn up a difference, but check the orders of the elements. And the orders of the elements is probably the most powerful tool that we have to turn up differences between groups. So I'll say one of these we can definitely do real quickly. There is a difference between which of these groups are abelian and which ones are not. Which of these doesn't belong with the others? D3, because D3 is not abelian. And the others are, right? Addition mod 6, multiplication mod 7, mod 9. Those are all commutative operations, and so the other three groups are abelian. So for sure, D3 is different. The question we didn't answer is, what about the other three groups? Are they different from one another? And since they're all abelian, and the orders of the groups are the same, the only way you have to investigate is to try to find some of the orders of those elements. And working through that kind of exercise will turn up whether you've got these topics nailed down for the exam.